All right, so now we get to talk about random numbers. One of the fun things about random numbers in computers is that computers are really bad about doing random numbers. Computers are deterministic machines. They hopefully should give you the same answer every time. If you see out hello world, right, you want to get hello world every time. It's deterministic. Usually when you're running a program, if you're randomly getting other things printed to the screen, this is bad. So one of the problems with all this is that sometimes you do want a random number, right? Sometimes you're going to make a role-playing game, you want to be able to roll a die or something like that and get a random result. And it's actually very hard for a computer to do that. You need to have sources of chaos as input into them. And some people have used lava lamps, which is kind of cool. So you can do a lava lamp. Do you guys know what a lava lamp is? Have you seen these things before? Lava rand. So here's a bunch of lava lamps. Add Cloudflare, that's fine. Full process is a true and unknown generator to the random seed, etc. So there was a patent actually on using lava lamps as a random number generator. Another approach that people do is random noise. Yeah, that's not what I'm looking for. So during the Cold War, they actually had satellite dishes pointed up at the skies. That's definitely not it. Not pointing at a satellite, not pointing at an asteroid or a planet or a moon, just pointed out at nothing. And they would collect noise and basically use this in cryptography and secrets and secure communications with secret agents and things like that. Because there are these things called one-time pads. And what you do, if you are doing a one-time pad, why is it trying to save? Okay. Just want to zoom in, but all right. Okay. So what you do if you're going to type like hello world, right, or something like that. So your first letter in hello is H, right? So H plus L is H. Is that right? Interesting. And then E plus F, F plus E is Q. But then H plus L is H again. That's funny. And then H plus L is, so we got three H's apparently. And then Y plus O is N. And so basically these are just random letters. And so what you do is you take the letter of your email or whatever, each letter, and you add the letter to it. So A plus A is Z, A plus B is Y, A plus C is X. So I guess these go backwards or something like that. And basically, if you take your letters and add completely randomly generated letters to them, then you have provably unbreakable encryption. So you have an encryption system that is provably random. You cannot break it. The people on the receiving end at Langley or whatever, they're going to do the opposite, right? So they're going to be like, okay, you typed in H, and the first letter of your one, because they have a copy of it, right? Like they give you a copy of the one-time pad. They keep a copy so that they can decrypt it, and then they read your first letter and they're like, okay, it's an H. So that's an H, cool. And then that was a Q. So they go Q and F is E, right? So they decrypt it using the same thing. Q plus F is E. So they get the H, E, then they get the L, the O. And so they're able to read your message back. Now, anyone want to guess how the Russians did it? How did Soviet Russia generate? See, we use technology, right? We have satellite dishes pointing at nothing, just gathering random bits of zeros and ones. How do you think the Soviets in World War II made random letters? They used lots of manpower. So they had rooms full of people, giant warehouses full of people, whacking on the keyboard like this 11 hours a day, just typing random characters in. Now, here's a question for you. Do you think that that's actually random? Like, if you're just like putting your face on the keyboard and just kind of rolling it left and right, if you are told to pick a random key on the keyboard, are you going to be very random, especially after the first minute and you get bored? Kind of random, but also not very random. And so the Americans got copies of a lot of the intercepts. Like the Soviets, during the Cold War, we went from BFFs to like, it's complicated, right? And vector, right? Commits evil with direction and magnitude. So we had intercepts of a lot of their messages it's into secret agents. And so we could actually decrypt them because the letters they picked for their one-time pad were not random. They tended to be around ADSF and HKJL, right? As people are kind of doing this. And so by using some very clever like an analysis of like how people randomly hit keys on keyboards, we're able to decipher a lot of these secret messages. These are called the Venona intercepts. And let's see if Venona is on here. And so we were actually able to decrypt 3,000 messages that were theoretically unbreakable. But they were breakable because the people were not actually generating random letters. For 37 years. We didn't tell anyone about it, right? It was only recently declassified. So it used to be, like when I was in high school, the case of Julius and Ethel Rosenberg, like a lot of historians thought they were innocent. And then the Venona intercepts were declassified. And, yep, they were guilty. So, they exposed Klaus Fuchs, which was kind of an interesting story. If you guys watch Oppenheimer. Imprisonment. And so he was a person who basically smuggled nuclear secrets to the USSR. Ken Philby, that's another hilarious story. So he was put in charge of finding spies working for the Soviets while being a Soviet spy. Yeah. Harry Dexter White. He was the guy who one of the guys who founded the IMF, the International Money Fund. He was like the assistant to Morgenthau in the Treasury Department. He was a spy for the Soviet Union. So interesting stuff. Sounds like a conflict of interest. Yeah, well, he didn't tell people that he was a Soviet spy. Yes. He's like, oh, really? Okay, yeah. I will hunt down your spies for you. So random numbers like really actually matter is what I'm coming to here. So it's actually really hard to generate random numbers. It's hard for computers to do in particular, and they have real world consequences if you don't do it right. For example, what if we're playing blackjack? Okay. So rand. So I'm going to generate a card from. Let's see out X. So I'm going to generate a pair of cards, right? These are my starting cards in blackjack. And I got an ace. I got blackjack. Look at that. Look at that. That is amazing. Please give me a round of applause in chat. Now, what if I run it again? What are the odds that I'm going to get a blackjack again? Time to go to the casino. I know, right? What if I ran this program again? Do you know what the odds are of getting blackjack? You have to get an ace, and then either a 10, Jack, Queen, King. So you got a 4 out of 13 times 1 out of 13. So that's a 4 out of 169, which is about 1 out of 40 chance of getting blackjack. Yep. Thank you. Thank you. Let's see if I can do it again. I got it again. What are the odds? Look at this. I am scoring blackjack after blackjack. I am the world's greatest blackjack player. No, man. The house never loses. No, I'm the player in this situation. So, yeah, there's something weird going on here, right? I'm calling rand. I'm supposed to be getting, this is a function. Rand, here's our first learning point for today. Learning point number 1. Rand makes a random number. I'm going to put double quotes around random. Okay. Between 0 and some large number. Okay. The minimum some large number is 32,000. In practice, it goes up to about 2 billion. Okay. Yeah. 1 million. So, but it's not random. Like every time I run this, let me zoom it. Every time I run, I get blackjack. It's not random. Yeah, the reason for that is because computers are terrible at random numbers. Okay? So, their rand is deterministic. It will always give you the same random number. Okay, now there's a function called srand. Seeds the random number generator. So I can pick a different seed, and then I will get a different sequence of random numbers out. So if I seed it with 0, oh look, I got blackjack again. Why? Because the seed defaults to 0. What if I seed it with 4? Now look, I'm getting a different series of numbers every time. Does that make sense to you guys? If I seed it with 42, I get a pair of, what was that, queens? A pair of queens every time. Yeah? But it's not random. It's not random. It's pseudo-random. It's deterministically random. It gives you the same random numbers every time you run the game. And that's useful in a lot of cases. Like, have any of you guys heard of this indie game called Minecraft? It might be too obscure for you guys to have heard about it. But when you make a Minecraft game, it's a pretty niche game, yeah. When you make a Minecraft level, there's a seed, right? And so if you share your seed with somebody, then they will get the same randomly generated world that you do. Same thing in Valheim. In Valheim, when you make a world, it tells you your random seed. And then if you want to share that seed with somebody else, then they will get the exact same landscape that you do. So to use rand, you'd have to infinitely randomize the seed. Well, let's try it. Yeah, sure. Let's put the stones within the stone. So let's seed srand with rand. Let's see how that works out. No, because it's still deterministic. Right, so we get the seed of 0 seeding something, and yeah. So the seed's the same every time. So what people tend to do is this. So they use the time to seed the random number generator, but that's still not random, right? That's still not random, right? You see that? The current time is in seconds since the beginning of time. Beginning of time was, of course, January 1st, 1970. So you can see, if I run it really quickly, I get the same random numbers every time. And, right, it changes every second. If I wait, I get a different one. If I wait, I get a different one. Right? If I run it really fast, it's not random, right? So would you trust, if you were a casino, would you trust this to randomize your shuffling of a deck? You know, you're going to deal out a deck of cards, and you're going to shuffle it, and you're going to seed it with the current time. Is that going to give you a, you know, random enough shuffle that players aren't going to be able to exploit it? Hazelton, how would you exploit this if you were shuffling a deck of cards using the seed as the current time. The seed for the srand seed is still 0. Yeah, if you use rand as you can't use rand to seed the random number generator. It just doesn't work. I would yeah, exactly. I would do a shuffle on. I would write a program, and I would shuffle my deck using the same seed that they're using. And after they deal out the cards in blackjack, I could deal out the cards on my simulation and see if I got the same shuffle. Because after all, they might shuffle it on one edge of a, like when there's a cutoff on a second, they might shuffle it at like 4.99. I shuffle it at 5.01. I might get a different shuffle. So what I do is I just have a program that would just sit there, and when I'd just deal it out and see if it matches theirs. And if I was off by 1, I'd subtract a second. Like, okay, now they match. And then I could just draw cards off the top of the deck. Hit me. Be like, okay, next card's a 2. Hit me on a 19. Win. Right? So blackjack is a very easy game to win when you know what all the cards coming up are. And so if a casino is stupid enough to shuffle their deck of cards this way, then players would be able to essentially be able to look at the next upcoming cards. You're playing poker, you know what every person has, right? Like, oh, you got a pair, you got a 4 of a kind, fold. Like this would be a very terrible source of random data, right? Because it's not random at all. It's just based on the time. And I know what time it is. You know what time it is. I know what time it is. We all know what time it is. So this is a terrible way of trying to randomize numbers. And so a lot of games and things like that, they don't even bother, right? It's like if you there's another indie game called Final Fantasy 12. You guys heard of this? 12? I think that's the one. Yeah, that's one. So in FF12, there is no srand. It's just whatever the default, or maybe it's seeded, but it's a fixed seed. And so when you open a treasure chest, it's a random roll, but they're fixed, right? And so what players would do is they would go and get into fights with monsters and stab things over and over and see what rolls they're getting. 42, 87, 99, 107, 22. And then they can see basically where they are in the predetermined sequence of numbers. And then they run away and they go to a specific spot and they open a box. And there's a 1 out of a million chance that when you open that box, which is right at the very beginning of the game, it's in like the starting cave, there's a 1 out of a million chance when you open that box that it will be the Zodiac Spear. And so what they do is they sit there and they fight monsters until they see the sequence of numbers that lead right up to that magic 1 out of a million roll. And then they run away. And then without fighting any other monsters, they open the box and they get the Zodiac Spear, one of the best weapons in the game. They fixed that, by the way, so you can't do that anymore. But that's what happens if you don't have any particular way of seeding your random number generator. So they just didn't. FF1 pre-rolled all of the dice rolls. So the NES didn't really have a random number generation system at all. And so what they did in FF1 was they just pre-rolled like a couple pages worth of random numbers. And then every time you needed a random number, it would cross one off and give you the next one. Then cross one off and give you the next one. And so they would repeat over and over again. And so if you're walking through the world, there's one, like you get random encounters when you walk through the world. Like you take 7 steps, and it goes, and you're in a random fight. But there's one sequence in that random number generator where you walk like a long ways, like 40 squares without a single fight breaking out. And I'd always know, like, oh, I'm in this part now. So I can like run, through this area and not have any random encounters. And so like I'd book it through like some dangerous zone and like no random monsters would appear. I'd grab a treasure and run out without getting attacked by anything. So there's a lot you can say about this. Computers are terrible. This has implications for cybersecurity, communications need random numbers, secure communications, we should say, both with one-time pads, and if you're going to like generate random primes, you need a way of randomly picking your prime. If your pick for prime numbers is not random, then people can hack your unhackable RSA encryption. Gambling, gaming, like it's an open question how we're going to do this. Now, it was very exploitable, yeah. Now, the good news is in this class, a lot of times I will actually tell you the seed to use. Like if we're doing any random numbers, I'm going to be like, yo, you're going to use a seed of 100 or whatever, right? And the reason for that is because my auto grader, I check to see if the output of your program matches the output of my program. And so I'll just tell you, use seed number 100, and then I can see if the numbers you're getting are the same numbers that I get, right? If you actually produce random numbers, I can't grade your stuff. So the good news is, a lot of the times, like it'll be like this. It'll be like int seed equals read. Please enter a seed. Like this. Right, and then my auto grader can work. I'll give you a seed, and then I check the output and make sure that it matches. So, creeping. Funny. Okay, so how do we generate? How do we if we want to do like a standard D6, like one of these things here. So for those of you that haven't seen one of these things, this is called a D6. In the biz, it's called a D6. So it's got a 1, a 2, a 3, a 4. There's the 1, there's a 2, the 5, where's the 5? That's the 6, where's the 5 at? There it is, that was under my thumb. There's the 5, and then the 6 on this one is actually the logo for a gaming convention down in LA, Strategicon in LA. And so every game that I volunteered to run at the gaming convention, they give you one of these dice. So I've got just collections of like volunteer dice essentially on my bookshelf and lying around here. So this is called a D6. And so when you roll it, I just got a 1. Okay, so it gives you a number from 1 to 6. So let's see how we can do this in a function. All right. So I'm going to make a function that's going to return an integer because it's a number from 1 to 6. So the return type is integer. The name of the function is D6. Doesn't take any parameters. And I'm going to do something like return rand, like this. But rand, remember, returns a number from 0 to 2 billion, let's say. And I want it to return a number from 1 to 6. So what I need to do is modulus it by 6. And when you divide any number by 6, you're going to get a number from 0 to 5. Right? So if 10 divided by 6 is 1 with a remainder of 4. So the remainder, anytime you divide something by 6, the remainder is going to be from 0 to 5. But that's not exactly what I want. I don't have a 0 on this die here. I have a 1 through 6. And so we go from 0 to 5 plus 1 to get 1 to 6. Okay? So 0 to 5 added 1 becomes a range from 1 to 6. So how would I do something like this? How do I return a number from 10 to 20? D10 to 20. So what do I put in here? Return rand modulus something plus something. What do I put in here? What do you guys think? How can I make a function that will randomly return a number? And by the way, rand is terrible. Maybe that's another learning point. Rand is terrible, but it is easier to learn in the C++ way. Whoever it was that designed the random number system for C++ hated you guys. They hated first-year students. This is something that I constantly have to harp upon whenever I meet committee members and things like that. Like, they constantly choose decisions that are not easy to remember. Rand is easy to remember. The system they came up with is not. So if you want to look at how you're supposed to do it, yeah, you got these things. MT19937 stood : Mersane _ Twister _ engine open bracket stood : you went fast 32 _ T comma 32 comma 64 comma 397 comma like what, you know. And then if you go to uniform int distribution, you don't have to remember all that, but you still have to remember MT19937. And so you first make a random device, then you make a gen using the random device, then you make a uniform int distribution with a distribution from 1 to 6, and then you can call this thing like it's a function, passing in the gen to it, and this will give you a number from 1 to 6. Congratulations. Look at how easy that is to memorize. That is the correct way of doing it, though. So if you guys are, in fact, caring about good quality random numbers, the C++ way is better. It's just not something that first-year students can realistically memorize. Rand is easy to memorize. Okay. So rand bitwise ANDed with 11 plus 10. Yeah. So if we do rand modulus 10 plus 10, this is going to give us, this part here is going to give us a number from 0 to 9. So adding 10 to it, we're going to get from 10 to 19. So that's off by 1. So if we wanted this will give us a number from 10 to 20. Okay. So this number here is kind of the range of numbers. There's 11 numbers from 10 to 20. So this will give you the appropriate range, the size of the range. And then the plus here moves the range into the right range. Right? 10 to 20. So if you just had this, rand modulus 11, that's going to give you a number from 0 to 10. Then if you add 10 to it, that gives you 10 to 20. Okay. So what you guys are going to do now is write these functions. So I want you to write these functions. Okay. Function called d10 that returns, I can't type today, returns a number from 1 to 10. xd6 that rolls xd6s and adds them together and returns the result. And we can do advantage for those of you that have played Baldur's Gate, that rolls 2d20s, 2d20, and picks the higher result. So for example, for advantage, if you roll a 14 and a 7, you get 14. If you roll a 3 and a 3, you get a 3. If you roll a 1 and a 20, you get a 20. If you roll a 10 and a 6, you get a 10. You roll 2 dice, 2 d20s, and you pick the higher result. For those of you that have played Baldur's Gate, probably recognize this. So you roll 2 d20, and you roll 2 d20s, let's say, and pick the higher result. Picks the higher result. Returns the high result. Okay. What else can we do? How about uniform int min int max returns a random number between min and max. So min is less than or equal to the number returned, which is less than or equal to max. Is the computer randomly being awful? Why your rolls in BG3 don't feel random at all? The game feels rigged. It is rigged. Out of the box, if you have not changed any of the settings in Baldur's Gate, the game actually rigs the dice. You can turn that off. And I turned it off, and then I got some of the worst amazingly bad luck rolls ever. So I ended up turning it back on because it fudging the dice rolls actually felt better than actual. Like I went like 3 rounds of combat with everybody missing, and it's like a 75% hit chance. Like the odds of that happening were astronomically small. I critically missed as a lucky halfling. A lucky halfling, if you roll a natural 1 to critically miss, you get to roll again and keep the second die. So in order for me to critically miss as a lucky halfling, you have to roll a 1 and then re-roll that and get a 1 again. And I critically missed twice within like 2 combats. I was just like, what the bloody hell is going on here? And so, yeah, so in Baldur's Gate, karmic dice will fudge the dice rolls. Turn it off for actually random dice. But I swear that game hated my halfling because he looks like Deadpool. So you missed a ton with 80% hit chance. I know, right? Like it just feels like the game hates you, and it doesn't feel random at all. And by default, it will fudge the dice. So if you miss a lot, then it'll make you hit, and if you hit a lot, it'll make you miss. So by default, yeah, it does. It does fudge the dice, but even if you turn it, like when you turn it off, like I got some of the most astronomically terrible results that I've ever seen in my life. Let's see if I can find a picture of my guy. It's like a halfling version of Deadpool. I'm playing a lot of Starfleet. Yeah, whatever. I'll see if I can pull it up. Okay, anyhow. So go ahead and write these functions now. And we will come back in half an hour and see what you guys got. All right, I'm going to pause the recording now. All right, and we are back. Here is my halfling ranger who, I don't know if you can, there we go. Streaming again. So there is my halfling ranger that looks like Deadpool. So the random dice roller absolutely hates him. So if we want to do a D10, it'll be very similar to the D6. It'll look like this, but instead of a D6, we're going to call it a D10. It's 10 wide, so there we go. That's all it takes. Looks like some solutions on here. D1 to 10. Sure, that's correct. XD6. That is not correct there. Advantage. First number is less. Return the second one. Otherwise, the first one. Now. Okay. So let's talk about this. So if you're going to roll 10 dice, you have to add them all together. So that sounds to me like a for loop, right? So we want to have int x die 6. So what we want to do is say for int I equals 0, I is less than x, I plus plus. So x times, we're going to roll a d6, right? So we're going to make a variable to hold that, and we're going to call d6 over and over again. So if we have 10 for x here, it's going to 10 times roll a d6, add all the results together, and then we need to return the result. If you don't return anything, you're going to get this warning message. And this warning message, you should consider an error, okay? If you don't return a value from a function that you're supposed to return a value from, it's really bad. This can actually cause your program to crash. So you really need to make sure, if you see this warning, like you might have like a return statement in here or something like this, you need to make sure that no matter which branch of code flow through your function you go, you are returning a number. And so here we will do return sum, and then we will be A-okay. But if you have like an if statement in here and you return from one of the branches and you don't return from the other, then that's really bad. And this can actually cause seg faults and crashes and things like that. So a for loop, adding together all the results, and notice that I am reusing the D6 function that I wrote earlier. Here, the user is, redoing it every time. But remember, when you are repeating yourself over and over again, if you've got a bug in your code and you fix it, you need to fix it every single place that you've got rand modulus 11 plus 10. You know, if you had an off by 1 error or something, you now have to go through maybe a million lines of code and look for all million places where you've got this particular pattern, and it just becomes a nightmare to debug. You want to put it into a function. Like here we had d20, right? Let's return that. 1 plus 20 plus 1. Now we've got a d20 function. You just call that over and over again. Okay. I don't think I did this right, and I didn't finish. That's fine. So d6 is fine. That's fine. That's fine. Yeah, don't input x, right? The assignment was x is passed in as a parameter. So main is going to pass x in. In general, if you can, I would almost never put cin and cout statements in a function. That's a little bit more extreme than I actually do. But if in a function like this where you're just supposed to roll a die, there shouldn't be any cins or couts in it. Okay, maybe cout if you're like debugging something and you're like, you know, you just want to see what's happening or something. But in general, functions they're kind of better if they don't have any cins or couts in them. Okay. And then what do we got here? Yeah, for loop and not quite done here. Yeah, okay. All right. So the one responsibility rule. Yeah. It's like main is going to read from the user, like, how many dice do you want to roll? 10. Okay. Then it calls xd6, passing in a 10 here. It rolls the 10 dice, and then it returns the result, and then main is responsible for printing it. Okay. And later on in CSI 41, when you learn about classes, you might have, main might not be in main, but the principle is kind of the same. Like you've got main that's responsible for the input and output, then it's going to call functions that'll do stuff and return results to it. So, so if we say int x equals read, cout x die 6. Main, anytime you're working with random numbers, there's another mistake that a lot of students make. Srand should appear once in your code. Unless you're doing something like deliberately like resetting the random numbers you're going to get. First line of main, set the random number generator based on the current time and just leave it. Some students I see do this every time, and srand 0. If you do this, you're going to reset the random number generator every time, and you are not going to get a random number. You're going to get the same number, like 7, every time. You will always get 7 or whatever number is randomly picked based on the seed here. Okay, do not call srand in a function like this, because you will not get a random number. The srand seeds the random number generator. That's what the S stands for. It seeds the random number generator. And having it once in main is enough. That's it. Everything else is going to be random from here on out. Okay. So if we do this, and compile and run. And so if we rolled 10d6, we got a 33. 10d6, we got a 28. I'm rolling bad. 31. Wow. RNGesus hates me today. I've got 4 different dice rolls under average. So 10d6, the expected value is 35. There we go. I got a 40. That's a good fireball. Okay. 10d6 fireball. Okay. All right. That was pretty poor rolling, though. What was the last one? Let's see. Advantage. Okay. Yeah, so advantage here. Int advantage. It's going to roll 2 d20s. And again, I'm not going to repeat myself when it comes to rolling a d20. I'm just going to use the d20 function that I got up there. So integer x equals d20. Integer y is equal to d20. And then I will return if x is greater than y, I'm going to return x. Otherwise, I'm going to return y. So this is something called the ternary operator. You guys have all seen it before, right? Ternary operator. We rolling some dice. We are. We're doing a little gambling up in here. No, this is D&D, not gambling. Gambling's for people that don't know math. Okay. Or, if you can compromise the casino's random number generator, it is a great gamble. if you know what numbers are going to be drawn in the Powerball tomorrow, it's a very good bet. I'm going to put $2 down on a $10 billion payoff or whatever it is. So gambling is for you because are you saying you're bad at math? Yeah, honestly, learning math makes gambling like not very fun, right? Because you're just like, oh, I'm handing you $1 and you're handing me back 98 cents. Then I hand you $1 again and you hand me back 98 cents again. And we're just going to do this all day long. And I'm going to be like, wow, this is so fun. This is amazing. No, it's not fun. I'm just handing money to a casino. Like, if I'm going to hand the money, I want to get like a buffet or something out of it. You know what I'm saying? Like, give me all you can eat crab legs. Fridays at Chuck Chansey. You know what I'm saying? Like, give me something for my money, not just on average a net loss. Now, sometimes you win, sometimes you lose, but on average, you're just handing the money every time you play. Okay. 90% of gamblers quit before they strike it big. I'm not a quitter. Okay. All right. So the ternary operator here is saying if x is greater than y, question mark. That's an if statement. If x is greater than y, then return x, colon, otherwise return y. If you want to do this using an if else, you can say if x is greater than y, return x, otherwise return y. Do I need an else statement here? Do I need an else statement here? No. Because if this branch is taken, it returns. It quits out of the function. This line of code will not run if I've quit already, right? So I could put an else there. The else is extraneous. Some students do. I don't, because it can't ever execute. Like it can't. There's no need for it. The code's the same with or without it. Okay. So this code here, these two lines here, is the same thing as the ternary operator here. Option 1, option 2. Another way you can do this is by using std max. So option 3, return the max of x and y, like that. You do that if you want. So you can pick. You can pick which one you want. cppreference. So it takes in two numbers and returns the bigger of them. Max of 69. Nice. 96. Okay. Yeah. You could actually do that, right? So for advantage, right, you could just return the max of D20, D20, and D20. One line. Boom. Done. Easier. Yep. Code graveyard with you. You're now in the code graveyard. All right. So, yeah. Baldur's Gate uses advantage. All right. So the last one here is uniform distribution. So you're going to return something in a range. It's a very common thing to do. Anytime you have like a dice game or something like that, I usually write a function like that. And I'm gonna write this one using the proper way of doing things, because rand sucks. Okay, so rand I teach because rand is easy. Okay, it's easy for students to learn and to memorize. But now I'm going to show you guys the proper way of doing it, and you can compare it for yourselves if it's better. Okay, so we're going to do int uniform. Int min, int max. Lord. Every time somebody, and like I said, this is something that like I hassle them about because nobody can remember it, right? Like nobody, like maybe if you do uniform int distribution every day, you remember how to do this, but like this is the setup for it. You know, and it's just, yeah. Okay, so I'm going to throw these into global space here. No. Copy. paste. Return. There. Now if I want to do this more properly without using globals here, I can paste it here and go static. Okay. And then instead of 1 and 6 here, we're going to have, ooh, that's static. Ooh. Can't do that. Okay. Min max. See out uniform from 1 to 6. That. And now we are getting random numbers the proper way. Okay. Do you guys see the difference in complexity? Like rolling a random number using rand. This is a D6, right? You need 1 line of setup, and then you just, it's a 1-liner to return a number from 1 to 6. This has 2 lines of setup, and then this god-awful thing here. And then this thing calls this thing, which calls this thing, which, again, like experienced computer science people, we just look it up on cppreference every time to do it. And then at the end of the day, we can call this function passing in any number to any number. So if I want a random number from, 1 to 60, like this, I can do it. Now, why is this superior? The quality of random numbers you get is superior. Rand is bad at actually making random numbers. The numbers you get out of it aren't random, or aren't very random. Like there's patterns in them and things like that. So it's supposed to just be a random number, but if you modulus it by 2 to do like a coin flip, you're not going to get like you're going to get patterns of heads and tails and things like that. Yeah, it's like the Russians in the in World War II. So rand is not good mathematically speaking. Like math people get upset at rand because you should not see patterns. Like you should just be getting random 1s and 0s, but there's patterns in it. And you can make the patterns appear in different ways by like modulusing by different numbers. You can actually see patterns appear in the numbers, which you should not have if it's random. And so the hashtag include random, the C++ way of doing random number generators is better. It gives you better quality numbers that don't have patterns. The seed here, whole system, like all that's kind of terrible, right? This will actually give you good random numbers, or good enough random numbers. It's just like, could you just give me a function? You know what I mean? Like, could you just make this part of the standard? And I think they're actually adding it. So this is something I've been kind of harping on for a long time. Like, just make it be easy for me to roll a d6. You know what I mean? Just like give me a function where I give you a minimum number and a maximum number, and just without me having to do it. Like MT 19937, like what the hell does that mean? What does any of this mean? Like first semester students like cannot memorize this at all. Experienced computer science people, we don't memorize it either. We look it up every time. And that's, to me, a sign of a bad design of a library. Not that the math part of it's bad. The math part of it's good. Just from a human interface standpoint, like, I would totally like forget that thing there, easy. It's just gnarly and and hard to read, hard to memorize. But if I was doing a casino, I would definitely want to use a higher quality random number generator than rand, because with rand, I could be taken to the cleaners by people who understand the patterns in rand and things like that. Okay. So here is the correct way of doing it. This will generate a number from whatever number to whatever number you want. If I want a number from 100 to 200, I could just call that function there. And there we go. Easy peasy. Okay. And you only have to do it once, you know, like you only have to make this function once. So, you know, is it that big a sacrifice? No, not really. But could I put this on a quiz? Could I put this on a competency exam? Probably not. You know, it's like, it's too hard for new students. So, all right. So that's random numbers. Hope you guys had fun. There's a lot of places where random numbers are used: gaming, gambling, security. Getting good quality numbers is important. So like if you're doing this for realsies, you know, use a real random number generator. But for like if you're making like Final Fantasy or whatever, like, you know, who cares? You know, who cares if there's a pattern? You know, you know, it's 1% more likely I'm going to roll a 4 on a d6. You know, nobody cares. All right. So that's it for today, guys. Thanks for coming out, and I will see you on Wednesday. Peace.